Okay, so let's take a brief revision of whatever we have done for the concept. By the concept map of the complete chapter, we have seen startingly with the gravitational energy exerted by the Earth. What is Earth's gravitational force? Secondly, we saw the planetary motion explanation by Kepler's laws. We have seen the first law, that elliptical orbit of the revolving motion of all the planets around the sun is elliptical. Second law, that is line joining and the planet and the sun sweeps equal areas in equal interval of time. And thirdly, we have that the time period of revolution, the square of the time period of revolution, is directly proportional to the cube of the mean distance between the planet and the sun. These are the Kepler's laws we studied. Nextly, we saw Newton's law of gravitation. Newton described the universal law of gravitation, that the force with which two objects in the universe attract each other, the force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So it was given as F is equal to capital G mm upon r square. That is, here the capital G was represented as universal gravitational constant. We saw how this universal gravitational constant was able to explain all the theories of motion of the planets, asteroids, and also high tides and low tides. Next thing, we saw the gravitational acceleration. That was given as Gm upon r square. Again, the capital G representing the universal gravitational constant, m the mass of the planet, and r square the distance between the planet and the object. Okay, so here specifically the gravitational acceleration was independent of the mass of the object, so it acts constantly on all objects over the surface. Next thing we saw, that is weight of an object and the mass. Mass is certainly different. The weight is nothing but the acceleration force acting on an object, that is given by mg, was equal to gmm upon r square. So that is the weight in newtons we saw on the surface of planet. Next thing we saw, the value of g that was going on changing with increasing altitudes, depths, and along the surface of the earth. Here, as we move up, the gravitation acceleration goes on decreasing its value. That is, it remains negative at certain heights and turns to zero at some level. And the gravitational acceleration, that is gravitational potential energy, is given as minus gmm upon r plus h. Okay, so now to escape this potential energy, we require some energy called as the escape velocity. We saw the derivation. Escape velocity is given as v escape is equal to root of twice gm upon r, where m is the mass of the planet and r is the distance between the object and the earth. Here the same equation was given by root of twice gr in terms of gravitational acceleration. This is the escape velocity. This is all the part. We saw the explanation of motion of falling bodies, motion of the moon around the earth, and motion of the planets, asteroids, and tides formation is responsible by the force of force acting on objects between any two objects in the universe. That is universal law given by Newton. We saw the explanation for the values of changes in g. Here at the last we saw the kinematic equations under the condition of free fall. What was that free fall condition? That is any object, if it is only under the influence of gravitational force alone, that was the condition known as free fall. So under that kinematic equation, we saw that the initial velocity being 0, the equations were given by v is equal to gt, s is equal to half gt square, and v square is equal to twice gs. Here the acceleration is the gravitational acceleration, therefore small g value was replaced to it. These were all of the objects, these topics what we have done, covered under this chapter. Make a map in this way, concept map. Go on with reading out all the topics. Make out your keywords and then the formulation to continue with the numericals in the next session. Thank you till then. Let's continue in the next hour.